Hello and welcome to this first video on the weaknesses of public key crypto systems. Remember that in previous lectures we've discussed two main types of approaches to cryptography. On the one hand, we had public key crypto systems or asymmetric crypto systems, and then on the other hand, we had private key crypto systems or symmetric crypto systems. Hopefully by now you're comfortable switching from symmetric and asymmetric to public key and private key systems in terms of terminology. So in this introductory video, we want to discuss or compare those two approaches on a couple of different dimensions. First, we want to look at their applicability. Is one more useful or more applicable than the other? So remember, the main goals of security are one, confidentiality, which we achieve by using encryption decryption algorithms. And in this case, everything we could do with symmetric crypto systems could also be done using public key crypto systems. So on this side, we discussed different ciphers, DES and AES and RC4. And on this side of the ledger, we discussed, say, the RSA algorithm. So in terms of confidentiality, these two approaches seem about as applicable. Then another goal of security, computer security, was integrity. So remember that in terms of integrity, we could either use a symmetric crypto system like CBCMAC or CMAC, in which case we would use a block cipher in CBC mode, and then we would use the last block or the CBC residue as the integrity marker. So we could do integrity with symmetric crypto systems, but of course we could also enforce integrity using public key crypto system, using, for example, a digital signature. So for both of these security goals, it appears that public key cryptography is at least as applicable, which I'm going to write down as a greater than or equal sign, as symmetric crypto systems. In other words, anything you can do with symmetric approaches, you can also do with public key approaches. So far, so good. But let's remember another computer security goal, which is that of non-repudiation. And here things look a little bit different. So remember that with symmetric crypto systems, because those systems use a private key that is shared by two parties, there is no way to enforce non-repudiation because either one of these two parties is not able to prove that the other party is the one that used the private key to perform some operation. Whereas in public key crypto system, there is indeed a private key that is only known to one person. So if that one person uses the private key to, say, sign a message, they are the only one who could have signed that message, and therefore they cannot come back later and say, "Oh no, I wasn't the one who did that." So the upshot of this is that in this sense, public key crypto systems are able to do something that symmetric crypto systems cannot do. So in that sense, public key systems are more applicable or strictly greater than, in terms of applicability, symmetric systems. So far what we seem to observe is that public key crypto systems are not only as applicable, but actually more applicable than symmetric ones. So the obvious question that should come to your mind then is, why are we still discussing symmetric crypto systems? Or why have public key crypto systems not completely replaced symmetric ones? And the reason has to do with another dimension of comparison, which is efficiency. So as we already mentioned earlier, public key crypto systems are actually much, much slower, sometimes orders of magnitude slower than symmetric crypto systems. And the reason for that is simple. On this side of the ledger, we have systems that use very fast exclusive or bitwise operations on the data. Whereas on this side, we're using extremely big prime numbers, for example, that we either have to multiply together or raised 1 to the power of the other. And these are extremely slow mathematical operations. So the upshot of this discussion is that both types of approaches are still being used, and neither one of them is going to eliminate the need for the other. So in the next video, we're going to discuss in a little bit more details the pros and cons of these approaches and whether we can combine them together.